Okay, let's go to page 41, and let's go and do number 44. Okay, it says, prove that the side of the trapezoid ABCD satisfy the condition, then the ABCD is orthogonal. Okay, so first let's go and draw the picture. Okay, so you got A, B, C, D. And you have the AB is parallel to CD. So you have AC squared plus BD squared equal to AB plus CD squared. Okay, so this is giving, and you want to show that the ABC is orthogonal. That means you want to prove that this is a right triangle. Okay, let's go and call this point I. Okay, so whenever you have to deal with orthogonal, what you need to do is you need to go and extend this and make it into a parallelogram. Okay. Okay, so let's go and call this point E. So what you do is make this into a parallelogram. Okay, so that this and this are congruent. Okay. Okay, so by extending that, you have the so from here we have, okay, so that's going to start. Okay, so you have AE equal to AB plus BE. Okay, so start with this. So AE equal to AB plus BE. And you have BE is equal to CD. So BE equal to CD because you're making this a parallelogram. So this is equal to that. Therefore, you can substitute this into here. So you have AE equal to AB plus CD. So what you want to do is you want to try to get into this. Okay, so we have this right over here now. Okay. And what we're going to do is we're going to square both sides. Okay. We're going to square both sides. So AE squared equal to AB plus CD squared. Okay. And what we're going to do is we're going to apply the law of cosine. Okay. So what we're going to do is we're going to use this triangle over here. We're going to apply the law of cosine for this one here. So law of cosine, and since we have this, right, so we want to use this as the long side. So we're going to have an AE square. So this square will equal to AC square plus CE square, right? So this square equal to this square plus this square minus 2AC CE cosine of this angle over here. Cosine of angle ACE. Okay. And so now we're going to substitute. We're going to substitute this. We're going to make these two equal because both is equal, right? So we're going to make these two equal. Okay, so we're going to bring it down here. So you got AB plus CD squared equal to AC squared plus CE squared minus 2 AC EC cosine of angle ACE. Okay. And since this one we're going to CE right over here, so we're going to change this into we're going to change that into, let's see, CE equal to okay, wait, okay, CE, oh, okay, CE equal to BD. Here you go. CE equal to BD, right? Because it's a paragraph, so we can change that. So we have an AB plus CD square equal to AC square. Okay. Again, we try to get something. We try to kind of apply that. Okay. Okay. So going to get B plus BD square minus 2 AC. I'm going to switch this. I'm going to make it into CE. Okay, I'm going to switch the letters. Cosine of angle ACE. Okay, and now we're going to do a substitute because this is giving. Okay, and again, the reason we do all that is so that we can substitute. Okay. The reason we're doing the switching because we want to be able to substitute this into here, okay? Because now we have these, right? This is giving, so we can change this into that. So this equal to that, so substitute. Okay. And we can minus this from both sides. So 0 equal to negative 2 AC CE cosine of angle ACE. Okay, then we can divide all these, so you can see that cosine of angle ACE equal to 0, and therefore angle ACE equal to 90 degrees. Okay. So this is 90 degrees. Okay. Now, because these two are parallel, this also is going to be 90 degrees, right? Because these are two parallel, so these two lines are parallel, so this is going to be corresponding angles. Okay, so we have DB is parallel to CE. Okay. And so therefore, angle AIB is congruent to angle ACE. Okay. So because it's the corresponding angles, are congruent, and therefore angle AIB equal to 90 degrees. So therefore, diagonals are perpendicular, and so it's therefore it would be orthodiagonal. Okay, and that's it. Okay, let's go to the next one. Okay, so you have a triangle ABC, and A is greater than or equal to B, greater than or equal to C, and you're giving A cubed plus B cubed plus C cubed over sine A cubed plus sine B cubed plus sine C cubed equal to 7. You want to compute the maximum value of A. So A max equal to question mark. Okay. Okay, so what you want to do is from what is given, what you can do is you can try to figure out what is the diameter. So you have a triangle, so you can find out the diameter of the circle that go around the triangle, and any side inside a circle cannot be greater than diameter, and it would be your max. So that's kind of the idea. Okay, and so from the formula, if you recall from the formula, if you have a triangle, so you're going to have the sine A equal to A over 2R, sine B equal to B over 2R. This came from the area. So the area of a triangle inside the circle is the area of the. So when you have a triangle inside, okay, so this will equal to, so the area of the triangle is also equal to 1/2 AB sine C, right? And this will equal to ABC over 4R, okay? And so if you simplify, okay, so when you simplify things a little bit, so A and B cancels out, okay? And then you multiply by 2, so you got sine C equal to 2C over 4R, and then you got sine C equal to C over 2R, okay? And then you're just switching the letter, right? Because triangle just rotate. So that's where these things came from, okay? And therefore sine C equal to C over 2R, okay? So again, sine A equal to A over 2R, okay? And again, 2R is the diameter. So again, if you draw a triangle, this would be like your hypotenuse, okay? Okay. So using that, and what you do is you just go ahead and substitute this into here, okay? So you have it. So you have a A cube plus B cube plus C cube over. So you cube this, you're going to get A cube over 8R cube. Cube this, put in here. So you're going to get B cube over 8R cube plus C cube over 8R cube equal to 7. Okay. And since these are common denominator, you can add this together. So you got A cube plus B cube plus C cube equal to A cube plus B cube plus C cube over 8R cube. Okay, so you just add this together, so you get that. Okay. And if you apply, okay, what you can do is you can multiply by common denominator, okay, to simplify the complex fraction. You can use, so if you put this over 1, so you can use outer over inner, and this will cancel out, okay. So outer over inner, so you got 8R cube times A cube plus B cube plus C cube over A cube plus B cube plus C cube equal to 7. Okay, and this will cancel out. So in other words, R cube equal to 7 over 8, and you take the cube root, so R equal to cube root of 7 over 2. Okay, and so the radius, so R is a radius of the big circle. Okay, so diameter, so the diameter with double that would be cube root of 7. Okay, and therefore, so the diameter of the circle is cube root of 7. So, and since the triangle is inside, so the maximum of any side, okay, no matter how you do it, it's going to be no greater than the diameter. So therefore, the A max is when, so when the triangle, when the side A is the diameter, then that would be your maximum length, okay, or cube root of 7. Okay, and that's it. Okay, let's go to next one. Okay, show that in triangle ABC. So you have triangle ABC. You want to show that sine of a over 2 equal to square root of s minus b, s minus c over bc. So you can notice the symmetry. If it a is over here, you're going to get b and c, right? Okay. So you have a triangle A, B, C. So use your identity for the half angle. Okay. So since you're looking for that, right? So let's use sine of A over 2, okay, equal to square root. It's a plus or minus, but since we deal with this, we're just going to do the. So basically, what we do is we're using the half angle formula right over here, right? And we're not going to deal with plus or minus because since we're dealing with physical object, so it's going to be positive. Okay. So this will give you 1 minus cosine A over 2. Okay. So we're going to try to find a way to relate this into here. Okay. So what we're going to do is, since we deal with A, so what we're going to do is we're going to go off to the side. Okay, we're going to use the law of cosine for angle A. Okay. So you're going to get A squared equal to B squared plus C squared minus 2BC cosine of A. And what we're going to do is we're going to solve for cosine of A and substitute into here. Okay. Okay, so we're going to move things around. So we got A squared minus B squared minus C squared. And then we're going to divide by BC, divide by 2BC. So this is equal to negative cosine of A. Okay, so you can move this down, so subtract, and divide. Okay, we're going to keep the negative over here because there's a negative over here, right? Minus cosine A, so we can substitute. So now we can substitute this into here. Okay, so sine of A over 2 equal to square root of 1 plus A squared minus B squared minus C squared over 2BC and over 2. The whole thing over 2. Yeah, don't forget it's over 2 over here. Okay, so now we're going to simplify this over here. Okay, so that's going this one is out here. Let me see. Oh, okay, let's redo this part over here. It's kind of messed up. Okay, so it'd be 1 plus A squared minus B squared minus C squared over 2BC over 2. Okay, that's more like it. Okay, so sine of A over 2 equal to, let's make into common denominator for this. So it'd be 2BC plus A squared minus B squared minus C squared over 2 BC is whole thing over 2. Okay, and so what we're going to do is this is going to be a perfect square. So I'm going to make into A squared and minus. So I'm going to regroup and so we can do factoring. And since there are a lot of minus, so I'm going to factor out the minus over here. So it'd be B squared, and this become minus 2BC plus C squared over, now when you have over 2BC over 2, this becomes 4BC. Okay, again, when you divide, you get 4. Okay. Okay, so now you get sine of A over 2 will equal to square root of you got a squared minus, now this become a perfect square. This is b minus c squared over 4bc. And now you can go ahead and factor in more. Okay, so difference of squares would be so it'd be this plus that times this minus that. So be careful with the signs. Okay, so now we got to find a way to relate this into the s. Okay, so let's go off to the side. Okay, so s, the semi-parameter, equal to a plus b plus c over 2. Okay, and if you multiply, so 2s equal to a plus b plus c. And since we okay, let's go ahead and let's just move minus the c over. Okay, so minus c. So 2s minus c equal to a plus b. Okay, so we're going to substitute this into here. So a plus b is 2c minus c. So we're going to get 2s minus c minus c. And we're going to do the same thing for here for a plus c. Okay. So you can go back over here. We have the 2s equal to a plus b plus c, right? So that's minus the b. Okay, so 2s minus b will equal to a plus c. Okay, so we can substitute that into here. Okay, so a plus c equal to that, so it would be 2s minus b minus b. Okay. And so this way becomes, so sine of a over 2 will equal to square of, so you're gonna, this way becomes 2s minus 2c, this way become 2s minus 2b over 4bc. So let's go ahead and move up here. And you can factor out the 2, so sine of a over 2. Okay, so factor out the 2, you get s minus c, and factor out the 2, you get s minus b over 4bc. Okay, so what I did is I factor out the 2, so it becomes that. Okay, and then 2 and 2 cancel with a 4. So sine of a over 2 equal to square root of s minus, I'm going to switch this over. Okay, so s minus b, s minus c over bc. Okay, and that's it. Check. Okay. Okay, let's go to the next one. Okay, number 47. Okay, it says use the last one to find a similar expression for cosine of a over 2. Okay, so for this one, let's go and use sine double angle formula. So sine 2 theta equal to 2 sine theta cosine theta. Okay, and so sine A will equal to 2 sine of A over 2, right? Because this will be half of that, so this half of that. Cosine of A over 2. And also from the area formula, area of a circle, area of a triangle is 1/2 AB sine theta, right? And so equal to 1/2 BC sine of A. and go and move things around. So sine A equal to 2k over BC. And so what we're going to do is we're going to just substitute into, okay, so we're going to substitute it into here, okay? So sine A is that, so it'd be 2k over BC equal to 2 sine A over 2 cosine of A over 2. And the sine A over 2, we have it from the last part, right? So we get 2k over BC equal to 2 times square root of s minus b, s minus c over BC. And you have cosine of A over 2. Okay. And now next thing what we're going to do is, okay, we can figure out what a k is. K, you use the Harris formula. So 2 times the area is equal to s times s minus a, s minus b, s minus c, okay, over bc. Okay, so this is the k, and equal to 2 square root of s minus b, s minus c over bc, cosine of A over 2. Okay, so now we can see this cancel out, s minus b cancel out, s minus c cancel out. Okay, then what we're going to do is we're going to multiply by square root of bc on both sides. Okay. Okay, well that's going simple. That's going wait. Okay, so right now we end up with s minus a over bc equal to 1 over square root of bc cosine of A over 2. Okay, then what we do is we're going to cross multiply, so we're going to get s minus a and square root of bc over bc equal to cosine of A over 2. Now this cancel out. This cancel. You're going to get square root of BC on the bottom. Okay, so you end up with s minus a over BC, okay, equal to cosine of A over 2. And that's it. Okay. Okay, let's go to the next one. Okay, number 48. You want to prove that area of the triangle ABC equal to r squared, cotangent of A over 2, cotangent of B over 2, cotangent of C over 2. Okay. For this one, we're going to use what we learned from the last two problems. Okay. So cotangent of A over 2 equal to cosine of A over 2 over sine of A over 2. So this will equal to, from the last two problems, this is square root of s minus a over bc, and you have the s minus b, s minus c over bc. So cotangent of A over 2 equal to square root of s minus a over s minus b, s minus c. Okay, so you can this over here. So bc will cancel out, and so you have this over this. Okay. Okay, again, just by the symmetry, okay, so cotangent of b over 2 will equal to s minus b over s minus a, s minus c. And cotangent of c over 2 equal to square root of s minus c. So whatever you have over here is going to be on the top. Whatever you don't have is going to be on the bottom. Okay, so it'll be s minus a, s minus b. And also from the area of the triangle, the RS equal to square root of S. So Hero's form, using the Hero's formula. Okay, so S minus A, S minus B, S minus C. So this is the K, right? Okay, so R equal to square root of, and when you divide by S, okay, so when you divide by S, this is like when you put it on the bottom, this will cancel out, so you're going to get S on the bottom, okay? S, so you're going to get S minus A, S minus B, S minus C. Okay, so you can think of this as the square root of S squared. So when you put it on, so when you divide, okay, you're going to end up with a square root on the bottom. Okay, so you can divide this, cancel with whatever on the bottom, you get that. So now if you put everything in here, okay. So area of a ABC equal to, so square of that, it would be S minus A, S minus B, S minus C over S times by this 3 over here. Okay, and so this will equal to, okay, so that's, so a lot of things can cancel. So this can cancel with this can cancel with this can cancel with that, okay, and this will cancel with this here, okay, and now notice this and this will give you the, so this divide by this will give you the square root of, okay, so first let's keep track. So you got S over here, this divide by this will give you S minus A, so that take care of this, and same thing, this divide by this will give you square root of S minus B, okay, this divided by this will give you square root of S minus C, okay. And so again, this is Hero's formula, okay? So check, okay? And so basically what we do is kind of go backward, okay? So to prove this is true, what we do, we start on this side and keep going, and so this becomes that, okay? So actually we substitute all this into here, okay? So you can see that you start, so you substitute all this into here, okay, and you can see they are identical. So you can prove that this is identity. Okay. Okay, let's go to the next one. Okay, the next one, the picture is giving. Okay, so you have A, B, C, D. So AD is the diameter, and here's the O, and this is the X over here. So we're going to draw this extra stuff over here. Okay. So number 49, you have this picture, and it says BX equal to CX. So this is congruent. So basically, they are symmetrical. And 3BAC equal to 36. So BAC equal to 12. So this is equal to 6 degrees. Okay, and angle BXC is 36. So this would be 18. Okay, so if this is 18, then this angle right over here would be 162 degrees. And okay, what else do we know? Okay. Oh, okay. So if the inscribed angle is 6, then this would be a 12 right over here. Okay, it would be double. Okay, let's see what else do we know. Okay, so let's go ahead and use the law of cosine. So for triangle AXB, so AXB, this triangle over here, and use law of sine. Okay, so you got AX, so this triangle, so AX over sine of, okay, so let's see. So we can figure this angle over here. So this is 162, and this is 6, so this angle right over here would be 12 degrees. Okay, so 180 minus that give you 18, or you can use this. 18 is external angle. External angle equals sum of two remote angles. So this and this have to equal to 18. So this is equal to 12. Okay. So AX over sine. So this over this angle, sine of 12 degrees, equal to AB over this angle. So sine of 162 degrees. Okay. And for triangle ABD, I'm going to draw this right over here. So for this triangle ABD, cosine of angle BAD, so BAD, so cosine of this, now this is a right triangle, so cosine of this triangle would be equal to AB over AD. So AB over AD, okay, that is your cosine of this BAD. Okay. So cosine of 6 degrees equal to, now AD is 1, right? This is is giving. Okay, let me double check. Yeah, so diameter is 1. Okay, so AD equal to 1. So it equal to AB. Okay, so we can substitute this into here. So AX over sine of 12 degrees equal to cosine of 6 degrees. Now, sine of 162, okay, use a supplementary angle equal to sine of 18 degrees. Okay, so these two are equal, right? Again, so you use a supplementary angle and move this over. So AX, okay, equal to sine of 12 degrees, cosine of 6 degrees over sine of 18 degrees. Okay. Okay, let's go to the next one. Okay, you want to show that if AD is the median of the triangle ABC, then that, okay? Okay. So again, you have a triangle, and you're going through the median. Okay, so whenever you deal with median, you need to extend and make into the parallelogram, okay? And let's go and call this M. Okay. And what we're going to do is we're going to apply the theorem, okay? Okay, so this is AD, so this will be double, right? So we're going to use a diagonal. So this diagonal will be 2AD squared, okay? Let's see. Okay, let's use. Okay, now let's use the law of cosine. Okay, let's do this. Okay, let's use the law of cosine.
Hello, quick announcement. The sophomores and juniors are in the gym, while the freshmen and juniors are in their